I've been a developer and a Kubernetes operator, a DevOps engineer for a long time. And the first time I saw eBPF, it's been so overwhelming because the word kernel programming in itself is intimidating, and it's very hard to think of meddling with the kernel and dealing with something at such a low level. So it's eBPF, which is always overwhelming for the Kubernetes developers and operators. So how do you basically explain this in the simple terms? As one of the strongest advocates and the champions of eBPF, how do you put that in the simple terms and make the Kubernetes community more comfortable about dealing with it?
Yeah, so I think before I even talk about what eBPF is doing, I'd point out that when we're running in a containerized environment, all of our containers or all of our Kubernetes pods that are running containers, if they're on a given node, on a given machine or virtual machine, all of those containers share a single kernel. And the kernel is the bit that interfaces to hardware. So if you want to do anything that involves, let's say, writing to a file, which involves a disk, or communicating over a network, which involves a wire, writing something to the screen, all of these things are going to involve the kernel, because the kernel does those operations on behalf of our user space applications. And the kernel is also coordinating all of our different applications that are running on the same machine. And it's taking care of things like permissions. Is this particular executable allowed to open that file? That kind of thing. The kernel's involved in all of those things. So that makes the kernel this very powerful place to instrument, to add security tooling, to add observability tooling. It's looking after the network. So, being able to change the way the kernel behaves allows us to kind of affect all these different things. Now, changing the way the kernel behaves used to be a case of either building your own kernel or writing a kernel module. And like you say, those are pretty intimidating things to do. And rebooting the machine with a new kernel is traditionally not something you want to do much in a live environment. But eBPF allows us to dynamically customize the way the kernel behaves. It allows us to load programs in dynamically. We don't have to reboot the machine, and we can affect the way the kernel is behaving. So it still is kernel programming, but it can be much sort of smaller and lightweight programs. And it's perhaps, well, to my mind, it's a little bit easier to start experimenting with. I don't think very many Kubernetes engineers will need to write eBPF programs, but they might find it interesting so they can understand, get a mental model, the same way that, most people do not need to write their own container runtime. And yet when I did a talk about writing essentially Docker in 80 lines of code, everybody loved that because it explains how things work. And I think that kind of just getting a feel for how things work gives you this really great position to understand how you use the tools that build on that technology.
Perfect. So for me, the icebreaker was your Python code snippet that you have written in your book, Learning eBPF. So the whole concept of splitting the code between the kernel and the user space and using Python as the language to load that module at runtime, it actually opened up a lot of opportunities and doors to me. In the sense, that's when I understood the power of eBPF. Where you can use a high-level language like Python, but still deal with very low-level plugins, that run at the kernel level. So for all those who are watching this interview, I strongly recommend you to read the book written by Liz on learning eBPF. It actually clarifies a lot of apprehensions, concerns, and doubts we have around eBPF. So Liz, on that note, why do you think eBPF is going to play an important role in the cloud native landscape, and particularly for the cloud native engineers?
Yeah, I think it really comes down to that ability to customize the kernel. In the olden days, pre-eBPF, if you wanted to change the kernel and have it deployed into customer environments, you basically have to get the whole kernel community to agree that that change is, a good idea and is useful to everyone. Whereas with eBPF, we can build much more customized programs that we can distribute to those who want to use them. We're not enforcing them into everybody's kernel. So we can have very bespoke tooling. And I think that's the real beauty of the tooling that's being built using eBPF. It can be very customized. It can be very specific to a particular environment. And it can be very powerful. It's also running in the kernel, so it can be very high performance. So we're seeing lots of observability tools. There's been some really great work over the years. I'll particularly highlight Brendan Gregg, who did a lot of work talking about using eBPF for performance measurement and tracing. And there are loads of tools that he's written and talked about and written books about that give you this ability to measure what's happening pretty much anywhere in your system. And I feel like that's the sort of the building block for, if you can find these command line tools that use eBPF to tell you, okay, tell me every time somebody opens a file, or tell me how much CPU is being used by these particular processes, or tell me how many bytes are being written to files on that machine. This kind of ability to measure things from command line tools, it's pretty natural to go from that to maybe more graphical observability tools. We have some really nice tools in Cilium. There's an observability component called Hubble. It lets you see individual network packets, but it also lets you build up a picture of how the services are communicating over a network. Or it lets you export information to Grafana, Prometheus metrics to Grafana. So you can get these really nice graphs that are built based on metrics that have been collected by eBPF. So they're very lightweight. They're not impacting the performance of the system significantly, but you can get all this really powerful and detailed information that tells you specifically the answers to the questions that you want to ask about your system. And that might be different from everybody else's deployments. And eBPF is giving us this kind of customizable power.